So our mission today, let's really unpack the critical differences between the traditional physical hardware HSMs and their newer counterparts, the software HSMs, these virtualized ones. Because look, if you're navigating the digital landscape, maybe building a startup, managing enterprise data, or you're just curious about what really keeps information safe, understanding this difference, it's key.
Absolutely. And this comparison, it really couldn't be more timely. With how fast virtualized environments have evolved and, well, the explosion of class native stuff, these software-based alternatives have become pretty popular. But here's the thing. These software HSNs, they simulate some core functions, yeah. But the reality, they differ significantly from hardware HSMs when you look at security assurance, compliance, even just how you operate them. We're going to break down exactly what those differences mean for you.
Okay, let's unpack this,
Yeah.
starting right at the fundamentals,
Yeah.
the architecture. So a hardware HSM, at its core, what is it? It's a dedicated physical device. Think of it like a specialized black box,
Hmm.
highly tamper-resistant, designed for one job, protect crypto keys and run secure crypto operations.
Yeah.
Contrast that with a software HSM. It's essentially what?
Okay.
A virtualized service,
Right,
or
yeah.
just software installed on regular general-purpose hardware.
Exactly.
So right at the bat, physical isolation versus logical, software-level isolation.
Precisely. And that core difference, it ripples out into how they're deployed, how they're managed. Hardware HSMs, they're either physical boxes you stick in your own data center on-prem, or they're managed physical hardware offered as a service, by cloud providers. Software HSMs, though, typically managed via software agents or maybe virtualized APIs. The key takeaway here really is that hardware HSMs depend on unique, physically secured components built to resist attacks, while software versions, they run on standard server hardware, sharing resources, with other apps.
Okay, so let's get to the heart of its security, because that's why these exist, right? This is where the differences get really stark, isn't it? Let's take FIPS 140 compliance. For anyone maybe not familiar, FIPS 140, it's a U.S. government standard for security requirements for crypto modules. So
Yeah.
why is it that hardware HSMs usually hit level 3, maybe even level 4, but software HSMs, they rarely get past level 1 or 2? What's happening under the hood there? What creates that gap?
Yeah, it really all comes down to their basic design and the trust model. Hardware HSMs are engineered with serious physical tamper resistance. We're talking features like environmental sensors, detecting changes in temperature voltage, and even things like auto-zeroization. If someone tries to physically mess with the device, bang, it detects it instantly, automatically erases all the sensitive crypto stuff inside, prevents compromise.
Wow.
Software versions, well, just by their nature, they don't have that physical protection layer. And key protection. Hardware HSMs make sure keys are non-exportable. They're generated, held securely inside a dedicated, isolated chip. They never, ever leave that secure boundary.
They're locked in.
Exactly. Locked in. Whereas software HSMs, they might encrypt the keys, sure, but they're stored in software vaults, and those vaults are still fundamentally just part of a software environment, which makes them more vulnerable, potentially, to software-based attacks.
That brings up something I find, well, fascinating and, frankly, a bit terrifying. Side channel attacks, things like electromagnetic analysis, pattern analysis attacks. We hear hardware HSMs are strong against these, but software HSMs, weak defenses, maybe none at all. Why is this specific kind of attack so dangerous, especially when we're talking sensitive data?
Well, they're dangerous because they're just so insidious.
Right.
They don't try to brute force the crypto algorithm itself. They don't attack the math. Instead, attackers analyze these really subtle physical clues that leak out during the crypto process. Tiny fluctuations in power use, maybe electromagnetic signals, even the precise timing of operations.
Stuff you wouldn't even notice.
Exactly. Almost imperceptible side channels. But from these, they can actually figure out the secret keys being used. It's dangerous because it completely bypasses all the mathematical security. It's a physical exploit, an environmental one. It can reveal your deepest secrets without ever cracking the code directly. So for you, the listener, these deep differences, they directly impact the trust, the assurance you can actually place in your crypto operations. It's really the difference between, say, a high-security bank vault and maybe a locked filing cabinet in a shared office.
That really clarifies it. How subtle but dangerous those attacks are. That physical layer makes a huge difference.
Okay.
But beyond just security, what about speed? Capacity. When you're dealing with huge amounts of data, global operations, let's dive into performance and scalability.
Yeah.
Hardware HSMs often have custom chips, right? ASICs, FPGAs.
Yeah, application-specific integrated circuits or field programmable gate arrays, specialized processors.
Built just for heavy crypto lifting. How does that compare performance-wise to software HSMs that just rely on the server they're on?
Big difference. Hardware HSMs are purpose-built. They're crypto accelerators. They can just churn through high volumes of crypto operations way faster, much better performance for high-demand situations. Software HSMs, well, they're limited by the general purpose CPU, the shared resources on whatever host machine they're running on.
Right. And scalability. How do you add more capacity?
That's another key difference. Hardware HSMs usually scale vertically, meaning you add more physical devices, more boxes.
Okay.
Software HSMs, on the other hand, they scale horizontally. You can just spin up more instances as needed. So they're really flexible, elastic,
Yeah.
especially good for cloud environments.
But there's a trade-off, I assume.
Always. Maintenance for hardware.
Mhm.
It involves physical access, can be more complex. Software, though, generally easier to update, patch remotely. Latency is also a thing. On-prem hardware HSMs, usually super low latency, they're right there. Software HSMs, especially in shared cloud setups, can have higher latency. Network hops, shared infrastructure,
Okay. So bring this down to earth. What does this mean for practical applications? Real-world uses. Let's take banking. Payments, it seems pretty clear there, right? PCI HSM compliance, the standard for payment card data security. It pretty much requires hardware HSMs.
That's right. Regulators simply don't accept software HSMs for those really critical financial functions.
So a bank couldn't just spin up some software HSMs in the cloud for a new payment system, even if it's cheaper. Regulators would just say no.
Pretty much, yeah. They mandate that highest level of assurance, and for good reason.
Right.
But flip side, look at cloud-native DevOps teams. For them, software HSMs often a great fit. They're lightweight, integrate easily container plugins, things like that. They offer the agility you need for, rapid development, fast deployment pipelines.
Makes sense. What about key management services? The systems that manage all the crypto keys.
Yeah, important one. Hardware HSMs are typically the go-to for protecting the root keys, the really foundational ones. The master keys that encrypt, well, basically all the other keys. Software HSMs can definitely manage application-level keys, less critical ones, but they're generally not used for those crown jewel master keys, the ones holding up your whole security posture.
Which ties straight back to the regulatory side, doesn't it? Hardware HSMs are built and certified for the strictest rules. FIPS, PCI. Non-negotiable in regulated industries.
Exactly.
Software HSMs. Useful, yes, but usually limited to lighter workloads. Dev test environments, places where that super strict auditable assurance isn't the absolute top priority. So wrapping this up, what does this all mean for you in the bigger picture? The core takeaway seems pretty clear. Hardware HSMs still the gold standard for high assurance situations, especially where absolute security and strict compliance are just non-negotiable.
Definitely.
But software HSMs absolutely offer compelling flexibility and scalability, making them a very viable, often cost-effective choice for, say, low to moderate security needs, especially in agile cloud-native environments.
Absolutely. Choosing between them, it comes down entirely to your specific risk profile, your compliance duties, your operational needs. It's rarely just a simple this or that choice anymore. In fact, we're seeing more and more hybrid models pop up, deeper cloud integrations too, trying to find that sweet spot, balancing performance, cost, and compliance. It's getting more nuanced all the time as the landscape evolves.
Which leads to a final thought to leave you with. Considering how fast cloud computing is changing and the threat landscape, cybersecurity threats just keep growing. How might this line, this distinction between hardware and software-based security, continue to blur, or maybe diverge even more? And what new challenges or maybe innovations do you think this could bring when it comes to securing your most sensitive digital assets? Something to maybe mull over until our next deep dive.